Good morning. As Mr. Stover indicated, I'm here leading a group of NASA retirees and some research scientists from industry in an independent assessment of the global warming concern that we've heard. A number of our research team members are here today, and I hope you would have a chance to talk to them and assure you these are not my own opinions, but pretty much the collective opinion of our group, that too much of the climate alarm today is based on climate models that have nothing to do with the scientific method. And that's my basic message today. Next chart, please. How do I move these charts?
Right there, the green button.
Green. Okay. I'm going to let this conference and other speakers at this conference convince you of my conviction that national security depends on energy security. And the anthropogenic or global warming climate alarm that's unsupported by physical data is a threat to our national security in two main ways that I can think of. There are probably many others. The first is it prevents rational decisions by our government regarding development of our U.S. energy resources. We heard a keynote speaker at breakfast talk about our vast energy resources and our ability to achieve energy dominance. But all this climate alarm, which is really mostly propaganda with very little evidence to support the concern, they're causing tremendous political bottlenecks in our government for doing the right thing. The other thing that has become more apparent to me as we prepared for this panel, our panel members researched or read a recent Harvard Business Review article about how our Navy is planning for alarming climate change and the extreme sea level rise predictions that are made by climate alarmists. And, you know, they're preparing for something that's unreasonable, that would cost too much money. We need to be preparing for accurate climate change, and we have the ability to accurately predict how much warming we're going to see this century. Unvalidated climate models, which means climate models that don't agree with physical data, predict the future global warming problems. At NASA, we have a policy. You can't make a design decision on a spacecraft or rocket. You can't make an operational decision about a spacecraft in orbit with a model that is not validated. You don't make critical decisions based on garbage in, garbage out. That is foolish. Yet our government has been doing that with respect to the climate alarm because too many academics in the universities are writing papers, drawing conclusions from models that don't agree with physical data. Dr. John Christie, who presented this chart to the U.S. House of Representatives in December 13, has met with our group, explained his research to us. He was here yesterday talking to some of us and talking in detail about this chart. And we all agree none of these models are believable. First of all, they don't agree with each other. That's a big red flag. And then if you average them, the average doesn't agree with the available physical data. Why would the UN even use these models if they knew they did not agree with the data? Alarming global warming predictions are not consistent with the scientific methods. At NASA, I mean, everything we did was consistent with the scientific method because we're after the truth. We're not just trying to get a paper published in a peer-reviewed journal. We're trying to get to the truth so we can make a good decision where people's lives are on the lines. The scientific method requires that your hypothesis and theories be confirmed by physical data. computer models are not physical data, although I think many in academia today don't understand that. Public policy and military planning should be based only on models that are validated by data. The other thing is, when you compare the few validated models that we have versus the climate models I showed on the previous slide, the validated models predict a lot less global warming. That is the right answer. The right answer is what the data says. The extent of global warming that we will see from greenhouse gases this century depend on two major factors. Everything else is kind of distracting you. One is we need some kind of metric that's a measure of sensitivity of Earth's surface temperature to the concentration of greenhouse gases in the atmosphere. Climate scientists have two favorites they use: equilibrium climate sensitivity, abbreviated ECS, and transient climate response, TCR. Both of these metrics depend on climate model solutions. And we looked at that. This is crazy. You need to have a metric that you can verify with physical data. So we defined a new metric called transient climate sensitivity, and it is how much warming will we see global average if we double CO2 in the atmosphere the way it's actually happening, with a very small amount of CO2 increase each year. We can measure that, and we can verify that. And so we use that as our metric in our climate model that we wanted to verify against available physical data. The other key thing you need to predict global warming from greenhouse gases is what the UN calls a representative concentration pathway. And that is an estimate of how carbon dioxide and other greenhouse gases will rise for the remainder of this century and beyond. And we took a stab at that too. We think the U.S. needs to establish an official data on these two key metrics. What is the true sensitivity of surface temperature to greenhouse gases, and what is a reasonable projection of greenhouse gas emissions and concentration rise in our atmosphere? I don't think we have that, and it's hindering our ability of our government to make rational decisions. I think it's also hindering our military from doing the accurate kind of planning they should be doing for climate change in the rest of this century. This is our representative concentration pathway. The data up until about 1959 came from ice cores in Antarctica. There's a short period of time where we have overlap between ice core data and more accurate measurements at Mauna Loa, which is the blue part of the curve. And then the red dash part of that curve is our estimate of how CO2 will rise in the atmosphere for the remainder of this century. Our projection was made from calculations that one of our members, Dr. Steckermeyer, who's here in the audience, he calculated that if you burned all of the known worldwide reserves of coal, oil, and natural gas that we, in our wildest imagination, could agree are in the proven reserves of the Earth, we could get 600 parts per million CO2 in the atmosphere. And then we looked at historical data and says, well, the warming effect of other greenhouse gases besides CO2 is very uncertain, but roughly about 50% of the effect of carbon dioxide. So on that basis, with our model, we projected how much warming we could get by the end of this century, and it's less than 1 degree centigrade. And that's based on what the physical data says. It's not speculation. This is how the climate scientists modeled the atmosphere and all of the physics going on in it to try to predict what happens if you double CO2 in the atmosphere. I'm going to use this slide just to get some consensus data on what are the energy flows into and out of the atmosphere. We modeled the climate system using conservation of energy, and this simpler diagram shows the part of the Earth's atmosphere that actually affects surface temperature goes up to about 14 miles. So it's a thin covering of the surface. And we show what's coming in from the sun in watts per meter squared, what's being reflected back out, a small amount going into the oceans, and then how much we reject to deep space by radiation from the Earth's surface. These are consensus climate science numbers, mostly measured. And then we write an equation that says the amount going out is equal to the amount coming in minus the amount we reflect minus the amount we put into the deep oceans. And we use calculus to determine if we have a small change in one variable, how big a change will we get in the other variables. The variable we're interested in is how much temperature change of the surface will we get if we reduce emissivity by increasing carbon dioxide, other greenhouse gases, and any effects changes in water vapor would have. And the equation we have that describes the greenhouse gas part is shown at the top of that slide. It's a very simple algebraic equation. And the temperature data from the Hadrut 4 database is shown in the dots there. And we find a constant, an unknown constant in this equation that causes this algebraic equation to fit the data. And we find that we can fit the data very accurately if our constant transient climate sensitivity plus 1 plus beta. Beta is the contribution of other greenhouse gases. We're saying that total amount of greenhouse gas warming when you double CO2 is 1.8 degrees. The CO2 part of that is only 1.2 degrees if you assume all the other greenhouse gases contribute about 50%. And that's a pretty good assumption. This is what we call a validated model. It's a rigorously derived equation, and it agrees with the physical data. There's not much uncertainty in that 1.8 degree number we have. So mainstream climate science has a factor of 3 uncertainty on what this metric is. And we think the true answer is at or below the lowest estimates of the UN IPCC. We think that climate alarm based on unvalidated models is really a threat to our national security for the reasons I said earlier. Our government is overreacting to the climate concern. And in particular, our military is preparing for unreasonable amounts of climate change. That's why we need a more official position of the government on what is the right sensitivity, what is a reasonable projection for the remainder of this century. We think we've done that. We offer what we've done to the scientific community, but we really think an independent scientific review of what's going on in the military needs to be conducted. The military should not be planning for what's coming out of the National Climate Assessment, which is basically propaganda. They need to be using accurate information. And I was kind of surprised that they aren't doing that now. So I think my time is up. I'll be glad to answer any questions later, and thank you for your attention.